Hello and welcome. In today's video, we're going to learn how you can build RAG application using JavaScript only. And this video is created based on the last week vote that I left in the video of creating AI agent using JavaScript. And I'm also gonna leave another vote in the description of this video for you guys to select what kind of video that you want me to create and focus on next. Without further ado, let's take a look what we're going to learn in today's video. We're going to start by understanding what is RAG and why we should use it and how it works. We're gonna create our first simple RAG using a search API. It's gonna be as a step one for creating a RAG example. Then we're gonna take it another step and understanding what embeddings and how to use an embedding database or vector database like Pinecone. Then on top of that, we're going to build an RAG application that's slightly more complicated than the first one using text and web scrubbing with a library like Shiro. Then testing this RAG that we build and show you an example of how you can handle PDF files, how to upload them, how to split them, how to do embedding on them. And finally, using Ollama locally instead of large language model APIs. We are going to build this project on top of Next.js. It's a main framework for this project, and I'm also using the same project code base for the last video, which is building AI agent using JavaScript, and also for the logic LangChain JS, make this project extremely easy. And for the embedding models, we're going to use Together AI, so go ahead and make your account and get your API from there. It have multiple embedding models that we can select and use from. And finally, create a free account in Pinecone, which is gonna be the vector database that we're going to store our embedding inside. We're going to create account inside Tivoli AI. It will act as our connection to the web, basically the search API engine for us. It's free, it gives you 1,000 requests per month. You can get your API key from here for free. And finally, any API for any large language model that you want, but in my case, I'm using the Google Gemini model from aistudio.google.com/app/API key. In my opinion, the Gemini 1.5 Pro is very good enough for this kind of apps, especially if you're starting out and using it to test what you can do with RAGs and agent. The first step that you're going to do is installing Next.js by copying this line and put it inside any empty folder that you have. And I'm using only JavaScript, no TypeScript. I'm not using the CRC folder, using Tailwind also in case if I wanted to take this project to the next step and create a front end UI for it. We're going to require a couple of libraries to make this RAG up and running easily. The first one we're going to use is Pinecone, of course, and Shiro.env for handling the environment key that we will have, LangChain, PDF parser, it will act as the parser for our PDFs to split every page, and LangChain core and community, and LangChain Google Generative AI, because I'm using Gemini, but in your case, it will be based on the large language model that you want to use. If it's Anthropic Claudia, you have to install Anthropic. If it's OpenAI models, you have to install the OpenAI. Then LangChain Ollama, because we're gonna test Ollama. I'm gonna show you how also to use Ollama as a connection instead of the large language model APIs. And finally, LangChain Pinecone, so you connect automatically to Pinecone easily. With that installed, let's take a look to what kind of environment key that we will require to set up this project. So as you know, we need any large language model API key. As I said, Google API key is very good. Then Tivoli API key, Together API key, Pinecone API key. And for the last one, the Pinecone database and index, leave it empty for now. I'm gonna show you how you can get it when we create our vector database index. I'm building on top of the last project that we created in the last video for AI agent in JavaScript. I created additional 4 different folder for each endpoint. One for Ollama to show you an example how to run Ollama. The other one for how to handle PDF files, uploading, splitting. and how you can get the metadata from them, how to create a RAG, which is the complex one, and finally a simple search RAG that we're going to build first. And each one have a road.js file inside them. And you don't have to follow me in terms of coding. I'm gonna leave you the entire code in a repo and the link you will find in the description. So you don't have to worry about coding anything. Just have to go to the repo, copy the code, or learn from it, or install it and using it however what you want. So inside search rag.js, we're gonna create our first rag. It's a very simple rag. It's not that difficult to understand and to do. We're going to import a couple of functions. The first one is the generative AI that we want. The Tivoli search results, both of them from the library that we install. And we're gonna import .env. It will automatically put the API keys environment from .env to the function automatically. And after that, we're going to create a simple get function that will handle the API point and try and catch block that will throw the error in case if anything went wrong. I'm getting the query from the API endpoint using the search parameters and sending through Q, which stands for query. After that, all you have to do is setting up the large language model that you use. In my case, I am using the Gemini 1.5 Pro and max output tokens is 2048. You can change this, scale it down, scale it up, however what you want, and give it the API key. And if I even remove the API key, it will work correctly. The next step is creating the Tivoli search results. This will handle the automatic search for Google search engine for us when we ask the RAG. And we can invoke it by giving it a query and it will automatically give us search results. And for our RAG to understand what we want from it, all we have to do is give it some sort of guidance. And the guide will be the prompt. Here we tell it you are an assistant for RAG questions and answering task. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say that you don't know. And the questions will be our query that we will get from the API endpoint, and the context will be the search result that we got from the Tivoli search results over here. And finally, we invoke our large language model that we created and give it the prompt and return a detailed response of everything that we'll get, like the response content, which is the result of invoked large language model, the questions, and the results of the search from Tivoli AI. So let's see it in action by asking it a simple question. So here our logic in action. As you can see, I asked it a simple questions. What is the best core workout to get fast results? And to see how it's done, you see this is all the stuff is what Tivoli AI gave us from the API. It went out and searched for this question and got back with the different results. As you can see, different titles and the URL for this kind of article and the content. And here, after giving all these resources to the large language model that created, it gave us this final answer. And as you can see here, it's summarized based on the article that it read. There is no one best core workout for the fast result, as everyone body fitness level is different, and it go on until it end the answer. As you can see here, it's formatted, but this is a JSON, so it's not gonna show us the formatted results unless we put it inside UI and parse it ourselves. But this kind of logic and RAG is the simplest RAG that you can create. It's basically you give it unstructured data or an article and tell it answer me from this article about my questions. This is basically the simplest RAG application that you can build. And here you can change the result actually based on the max result that coming back from Tivoli search results. Here I put it 10, can put it less 5 or 3, and based on the information it will get, it will change its answer from the large language model. We build a simple RAG example to get it up and running and see how it kind of works. But let's understand what is RAG. RAG is a technique for augmenting large language model knowledge with additional data. And it stands for Retrieval Augmented Generation. As you know, large language model can reason about wide range of topics like coding or summarization of text or generating text. but their knowledge is limited to the public data up to the specific point in time that they are trained on. Basically, if it's trained until 2022, it doesn't know anything beyond that. If you wanted to build an API application that can reason about private data or data in certain domain, and the large language model doesn't have any knowledge on information that it needs, then the process of creating a RAG application solves this. So here is a simple image showing how RAG is basically built. We have some sort of data. It can be a URL, JSON, kind of Excel file, PDF, code, text, and even images that you take. It's unfiltered, it's not structured, and you take it and split it to chunks. And we're gonna do that actually. Each chunk could be 1000, 1500, or 2000 of words. And these words get to turn to embedding. Embedding is a process of turning each word key values to some sort of array with number. And we store this embedding on side database that's called vector database, like Pinecone that we're going to use. And when we go to interact with this RAG, we ask it a questions. What happened is basically this question got into the prompt, and also we get this question send it to embedding, and this embedding will go search inside our vector database and retrieve as similar results as it can be, and send these results to the prompt also. And we give this prompt with the questions and the retrieved embedding results to the large language model. And the large language model will give us the final answer. This is basically what the core logic of RAG. You can build RAG without any frameworks or with framework, but this is the same exact steps that you need to do when you're building a retriever augmented app. Now we understand how RAG and how it works. Let's go and build a real one. Now let's create our index inside the vector database. I want you to go to Pinecone and log in and create a new index. This new index will need some sort of name, and this name we're going to use it to connect to our database. I'm gonna call mine the RAG Q&A for short for RAG Q&A, and we need to put the dimension. I got this dimension for the model that I'm going to use. The model that we're going to use is from Together AI. Then I'm going to select the cloud provider, which is WES, and then select the region and create index. If you selected the Google Cloud, it's going to be pricey, but if AWS, select the region Virginia and create index and give it a couple of minutes, it will automatically create your index for you. Now, as you can see, there is two different stuff that you need to take from here. The first one is the RAG Q&A. It's the name of the index. The second one is the database, which is the database URL, which is here, that you need to take under the name host. We're gonna copy these both of them and put them inside our env file. And here we're gonna put the name RAG Q&A. And here we put the URL of the database that we copied from the host. And finally, the API key. Right now, we can use this vector database index to connect it to our embedding. And first step is importing the function from the libraries that we're going to use. We're gonna need Shiro or the web scraping and Together AI embedding that we're going to use Together API in this one. A function called create stuff documents chain, then chat prompt template to give it the prompt that we want to create, and chat Google Generative AI once more, and string a web parser and Pinecone store and Pinecone as Pinecone client, and finally .env and the .env initialization. And once more, we're creating a function that's AI get API point, and inside it, a try and catch block. Inside this try catch block, we're gonna put all our logic here. I know it's not the perfect kind of way to do it if it's a real project, but this is just for learning how to do it. The first thing that we need to do is creating the Pinecone client and the Pinecone index. This will automatically initialize the database vector that we have in our Pinecone index. Then we're going to create the embedding model that we want to use. I'm using a model called the M2 part 8M8K retrieval. You can use it for free on Together AI. All you need the API key. It's this model over here. Do embedding in 768 dimension. So remember this number because this is the number that we bought in our index dimension. And the context windows of it is 9000 and there is even larger one, which is the M2 part 8M 18M32K retrieval. This model actually is even better, same dimension, but with more context window. The rest is kinda, I didn't use it because all of them is kinda small, as you can see. And next step that we're going to do is creating something called vector store. The vector store will be our Pinecone store that we got from LangChain and Pinecone. This Pinecone store will take the embedding function that we created over here from Together AI embeddings and the Pinecone index that we want and the maximum number of requests that allow at once here. It's 5. So the next step logically will be getting some sort of text that we want to store and put inside our vector store as embedding. I'm gonna get simple page from Lining Wing, GitHub post about agents using the Shiro web-based loader, which is basically return the entire text over here and take these docs and split it by using something called text splitter. Text splitter is also a function that we get from LangChain for without doing anything. All I have to do is give it the chunk size that we want. Here I bought 2000 and I bought 2000 for a reason. If you bought it 1000, you will get error with Together AI embedding calling you out for the rate limit because you're sending too many requests at 1 minute. All you have to do is just increase the chunk size. I bought it to 2000. Then the chunk overlap. Basically, how many common words between the first chunk, the second chunk is 200. And this text splitter will split the documents that we got, the docs that we got from the loader, Shiro web base loader. Let me show you how it will look at this point. So if we head to our API rag, we will see the array of splits over here, and inside it bunch of objects, and each object have base content that have some sort of text here that I got from this page that we fetch, and metadata. The metadata here is the source and the log. Inside this log, the lines from 3 to 101. And if we went down slightly, as you can see here, there is overlap between this one, the Llama powered automation agent, and as you can see here, there is also the same text. This is the overlap that I show you, the 200. Same thing, base content, metadata, lines from 99 to 157. This is basically the split that we're going to use to embed and send it back to the vector database that we have. Before proceeding to the next step, I'm going to create a simple function that will give me a generated number strings from array lengths. I'm going to explain why in just a second. Just create a simple function that will return array of strings based on the lengths of array that we will give it, and pass it here as the number IDs. Why I'm doing this? To save anything to Pinecone, which is the splits that we show in the API key, we need to give it IDs. Why? These IDs will act as the control for us when we want to delete or update in case if we want to do the embeddings. This number IDs will basically be array of string like 1, 2, 3, 4, 5 until the end of the lengths of the splits. We have here about 39 split links, and here it will generate from the array from 1 to 39. And with that, we actually can run this function and see the embedding inside our vector store. But be warned, don't run this code multiple times. Only run it just one time because we don't want to get duplicate inside our embeddings. So after running, just comment it out or basically copy it, put it inside other place or a function. So we don't call it again. After I called the function, about few minutes later, I went out to my index, the rack UA that we created together. And as you can see here, there is multiple index, multiple values inside this index. As you can see here, the ID is 32. Let's go to ID number 1 by selecting list fetch, and it will get a list of IDs and select the number 1. And here, as you can see, it's basically the text that we saw inside our split API over here. As you can see here, page content, this stuff that we over here, we got to automatically it's basically the same thing over here. And the metadata that we have, as you can see here, from third line to 101, the source is over here. This is basically our vector database. This is very powerful because if you store it in a vector database like Pinecone, for example, which is the most famous one currently, you don't have to worry about memory handling or if something went wrong. It's just saved in a cloud. You don't have to use something like a vector search, vector store memory, which is kind of sucks, honestly. So use Pinecone instead. With that, we are ready to query this database and get results when we ask it. Go back to our code and comment the fetching text, splitting the splitter and the splitting process, and the generation of the number IDs and the saving function into Pinecone, because we don't want to run it again. Next step is creating a retriever. This also will be from the vector store that we created, and it will return the first top 10, top 15, top 20 search result that it got from the database. It's like our query results. Then we're gonna need also some sort of guidings to control our RAG. Here, I am using a prompt already I got from the Lang hub that handled basically building Q&A RAG with a retriever documentation. It's similar to the one that we created, but it say here use 3 sentence maximum and keep the answer consents. I can remove this. It will basically be longer. A short answer will be created when using this prompt. And I give it the question, the context, and it will expect an answer in the end. Then create our large language model that we want to use. Same thing here, nothing changed. And here, the most important part is the same function, but we give it different thing. Here, create stuff, documents chain. It will act our rig as a rig chain. We give it the model, which is that we want to use, the prompt that we have over here, and something called our parser. The out parser will be also a function. We get it from LangChain. It's called string out parse. It will parse the output of our model using this prompt. Here is the first part of activating this RAG. We need to send the retriever question that we want. So we can query our database to get us the results that we want. Basically, the first top similar results that we'll get, I here put it to 15. You can put it below that. And the questions will be, what is the text? What is task decomposition? This is the question that you find actually task composition inside the article that we fetch from this link. As you can see here, there is something called task decomposition, and I wanted to go inside database and fetch information about it, summarize it, and give us an answer. So the first thing to fetch it from the database or the vector database, then we give the same questions to our RAG chain that we created by invoke it, and also give it the retrieve docs that we got from the vector database. And with that, we are ready to see the final answer by returning a response.json that will give us both the retrieve docs. You don't have to see this actually, and the results in the end from the RAG that we created. And this is basically the answer that we get. Actually, we get it very fast because the vector database is extremely fast. Let's take a look to the results first before we take a look to the retrieve docs that we have. Here it tell us the final answer. Task decomposition is a technique for solving complex problems by breaking them down into smaller, more manageable tasks. And go on to the end of the answer. And here to retrieve docs, as you can see here, it tried to fetch any information about the task decomposition or the mention of it And as you can see here, there are different ID 31, 14, and 39, 12. So it's all over the place based on what it found in terms of embedding similar to the question that you asked it. And after that, it take all this base content and give it to large language model and tell me answer the questions that we sent it. And with that, we build an actual function RAG that it act right now super fast. It's not complete yet. You need some sort of front end UI and you need to make it more easy to query. Right now, it's a static questions, which is not correct way to do that. But yeah, you get the point. You can build on top of it and make it even better. Right now, let's take a look how we can handle an actual PDF files. Because most of the people that build RAG build it with PDF files. Inside our PDF files folder, we're gonna create the simple logic to basically parse a PDF that I already have. The first thing that we need to do is import libraries that we're going to need. When it comes to PDF, it's slightly complex, but it's also very easy using LangChain. Well, we need PDF loader to load our PDF. Then we're gonna need also the text splitter for splitting this PDF. And then we're gonna create a get API point function and try and catch error block and return error if anything went wrong. Here we have simple function called PDF loader. We give it the URL of a PDF that I already have inside the public folder of Next.js, so anyone can access it. In order to use this loader and get your documentation, we have to use it by invoke load function. Let me show you how it looks right now without splitting anything as a raw data. If you want to API/BD files, you will find the same thing almost in when we did the split on the text array with multiple objects, and each object have base content and metadata. The base content have text and the metadata have information about this text or the PDF in our case. Here, as you can see, let's take a look to the second one, the base content. It's some sort of text, and then the metadata, the source of the name of this PDF, where you get it from, the version of the PDF formation, some sort of information about the title, who wrote it, producer, all this kind of stuff, the creation date, a lot of information about the PDF actually, and the amount of pages that inside it. So once more, we're gonna create a recursive character text splitter. With this time, it's 1000 chunk. I feel like 1000 just right to show you. I'm not gonna embed it because you already know how to embed stuff right now using vector database and which model that you can use to embed stuff. But let's see it in action. As you can see here, it's also same, but the only thing that changed inside the metadata object, you will find another information, the page number, the lines that went from 1 to 26, and here from 22 to 39, and also doing the same thing with overlapping. And if you want to embed this PDF, all you have to do is follow the same example last time that we did, generate numbered string array for the IDs and save it to Pinecone and initiate the vector database on top and create the embedding model and pass the stuff to the vector store, then use this vector store to add the document that we created, here the splits and the number IDs that we got. And with that, we have a new embedding PDFs inside our database, but I'm not gonna do that. You already know how to do that right now. So there is no point of showing it to you again using PDFs. So the last thing that we're going to work on is using Ollama instead of large language model, which I think a lot of people is excited about. Before we write the logic of running locally Ollama, we need to download it first. If you don't have Ollama on your machine, follow this. If you already have it, just skip it to the part of starting the code. You need to download Ollama based on the operating system that you have. I'm using Windows, so I download it for the Windows, and I'm gonna follow the installation as it is simply. And after that, we're gonna need some sort of large language model that is small enough to run it on the GPU, and it will be very good at summarization. For example, the Llama 3.18b is excellent for summarization. This version, the Llama 3.18b, It's about 4 gigabyte and a half. It's very easy to download. At any terminal, you copy Ollama, run Llama 3.1, and select this version that we have. It will automatically download the 8B for you. A model like 7B and 405B billion parameter is too much to install. Just download the 8B, it will gonna be fine for you. In my case, I'm using the Codewello model that I uninstalled when I was creating the tutorial for how to create an offline copilot on your machine. So I'm gonna use this one. You can use whatever model that you want. So the first thing that we need to create is the function that have an endpoint and the try and catch block to handle the errors, and calling Ollama from the LangChain Ollama, and give it here the name of the model that we want. Usually, 100% of the time, Ollama run on the local host 11434. And if you follow this link, you can see here it tell you Ollama is running. Basically, that means that Ollama is running in the background and ready to use any model that you want. And we give it here the name of the model that I wanted to use, which is Codewello. And we use this Ollama as any function in LangChain by invoke it, and I see here hello world. Let's see it in action and see if it's work or not. And inside the API, Ollama API endpoint, I see hello, how I can assist you today. So it's working and it gives us an answer. So this is basically how you can run Ollama. It's very simple. Instead of using the generative AI from Google, you can switch it out with the function that we just created from Ollama and it will work correctly. But based on the experience that I see, that Codewello is not good in summarization. It's for coding, so I'm not gonna use it as a summarization for the context that we have. This is why I recommend the Llama 3.1 8 billion parameter model. It's excellent when it comes to summarization and text generation. And with that, we are done with how to create a RAG in JavaScript only. This video is created based on a vote. Once more, I have to tell you that because you are guys that decided to vote for this video. So I'm gonna leave another vote here, the link for it in the description, to vote for what you want to see next. Maybe you want to continue in JavaScript series, creating another AI app using it. If you've enjoyed this video, please hit the like button. It will help my channel a lot. It will signal for YouTube algorithm that this video is good enough for people to watch and he can learn from it. And if you found it not that good, please hit the dislike so I can know also. And don't forget to subscribe and see you in the next video.